Hello and welcome to this video on VLSI physical design. So this will be a very quick tutorial on static timing analysis, and we will be doing on chip variation and clock reconvergence pessimism removal. So first of all, what is the on chip variation? So during the manufacturing of chips on the same die, there may be variations due to process or voltage or temperature change. Thus, different transistors can be faster or slower in different dies on the same chip. Then, delays can vary across a single die also due to process voltage and temperature variations. So, for example, the delay value of IC in cold weather is different and in hot weather is different, because in cold weather the metals shrink. So obviously the delay will decrease because the path length will decrease, whereas in hot weather the metal will expand, so the path also increases, so the delay will increase because the signal will have to travel a longer path. So this is called as on chip variations. So to compensate for these variations, we have introduced a concept of extra timing margins, which are called as derating values. These are added in timing analysis. So these bring more pessimism and they compensate for this variation. So due to this on chip variation and derating values, what happens is that the faster path becomes more fast and the slower path becomes more slower. And basically OCV adds some pessimism in the common path of launch and capture path. So for a same cell there will be two delays. First is the minimum delay and second is the maximum delay. This is due to on chip variation. So for the same path we will consider two type of delays, which are the maximum delay and the minimum delay. So consider this example. So in this figure we have three buffers, BUF1, BUF2 and BUF3, and two flip-flops. The first is the launch flip-flop and the second is the capture flip-flop. So as you can see, for the different cells we will have different type of delays. So for example, you can see here for buffer 1 we have the minimum delay 0.60 and the maximum delay is 0.70. Similarly for buff 2 we have different maximum delays and minimum delays. So consider this. First, there are two paths. The first is the launch path from buffer 1 to buffer 2, the first flip flop, then combinational logic, then finally the capture flip flop. And the second path is the path for the capture flip flop, which is from buffer 1 to buffer 3 and finally to the second capture flip flop. So here BUF1 is common point between launch path and capture path. Both the launch path and capture path will consist of this common point, which is called as BUF1. So this is the concept of on chip variation, that we will be having two type of delays, maximum delay and minimum delay. And the OCV will add some pessimism in the common path of launch and capture path. So we will consider different delays, maximum delay and minimum delay for BUF1, because BUF1 is common between the launch path and the capture path. Now, but practically if you see, then we cannot have different values of delay for same cell. See here BUF1 is the same cell. So the same cell cannot behave different for different clock path, because we are considering that it is providing the minimum delay to the launch path and maximum delay to the capture path, but this cannot be practically possible. So because the cells along the common portion of clock tree cannot simultaneously achieve their maximum and minimum delay values. Obviously either it will provide the maximum delay or it will provide the minimum delay. Thus there will be a single value of delay to the common point that will be propagated to both the launching and the capturing clock path. So this is in conflict with our on chip variation timing analysis method described, which we have just described. So therefore our timing report will contain artificially introduced pessimism, that is the concept of clock reconvergence pessimism removal. So here we can see that for BUF1 the maximum delay is 0.7 and minimum delay is 0.6. So here the pessimism that we have introduced is of 0.1 and let it be nanosecond. So if we subtract maximum delay from from minimum delay for BUF1, then it is called as 0.1 nanosecond. So we will remove that 0.1 nanosecond from the common path. This is the extra pessimism that we will remove, because when we added the delay to every buffer in on chip variation, then it also affects the speed of the chip, and as we have studied that same cell cannot behave differently for different clock paths. So therefore we will add, to overcome this, we will remove the delay to the common path in process of CRPR. Thank you. Please like